Alrighty, so now we're going to be identifying functional groups. And a lot of this is memorization. You're going to have to do this on your own. I'm going to try to give you some tips in this video that helped me, but ultimately you're going to have to probably practice your own. You can go to Canvas. Oh, actually, I should probably stop annotating. You can go to Canvas and in the last unit, chapter 15 here, I just clicked on that link. I went down below all the videos in between supplemental worksheets, and this is the functional groups. This one is a little weird. It's just like an extra one, but or wait, or no, this is the one. Yeah. This one has the key connected to it. This is the one that's a little funky. This one is okay. Um, th yeah, this one right here. I would just click this one, do it. This is the one without the key. I was just looking, making sure all my entries are okay. So you come over here, and now I'm going to annotate. Yeah, okay. So here we see just a bunch of hydrocarbons, like excluding this little connection right here with that carbon double bonded to oxygen. That's called a carbonyl. It's not a functional group. It is just a type of bond. It's like a carbonyl bond, or a carbonyl um, group. It's not a functional group though. But what I see here is three carbons bonded. These are the three carbons bonded together, and then there's a carbonyl inside of it. And usually what that means is that it has a ketone functional group because ketone has three carbons. It's always going to have three carbons, and one of these carbons is going to have a oxygen double bonded to it. It has to have the oxygen double bonded. If it was just like this and it just had an O connected to it, that would not be ketone. It has to have the double bond. And so I'm going to put ketone here. And we're going to move on to the next one. This one is, I just see a bunch of hydrocarbons, and then I get to this one right here, this little functional group right here. And here you might be tempted to say, this is an alcohol because it has carbon, oxygen, and hydrogen. But you have to realize that within this like little group area here is a carbonyl. Now, an alcohol is just going to be COH, like a bond like that. All of them are going to be single bonded. But what is very similar to alcohol that has a carbonyl in it is aldehyde. An aldehyde is going to be CH, and then also this carbon is going to be connected, double bonded, not just connected to oxygen with a single bond, but double bonded. And so this is going to be aldehyde. Once again, this is going to be kind of like practice on your own. Get it to so that it makes sense to you. But these are some tips that I have. But once again, you're probably going to have to go through this on your own and figure it out. And I do recommend doing this sheet if you're having troubles with the functional groups. Okay, so whenever I go down here to the third one, the first thing that I see that is different than all of the other ones is that there is a double bond between two carbons here. And immediately when I see that, I think, oh, this isn't even an alkane because alkane is only like single bonded, single bonded, single bonded. This is a double bond, which is actually going to be an alkene. But there is also another functional group in this one, which I pointed it out to you earlier in the last one, is the COH here. Remember what COH is? That's alcohol. If you remember, alcohol. Alcohol. And so it's going to be alkene and it's going to be alcohol. Alrighty. Now we're going to clear and we're going to scroll down. Alrighty. I can get the marker to come back up. There we go. Oh, did I get it? Okay. Now with this one, I see a carbonyl, carbon double bonded to oxygen. And it's also connected to a hydrogen here. So instead of it being COH, like a regular alcohol, it is C double O, double bonded OH. And that is going to be aldehyde. And this little like a bonding thing, it's incorrect. Like the hydrogen is not bonded, but it's just to show how similar these look whenever they're in structures like these. This hydrogen is always going to be bonded to the carbon, right? Um, and then the carbon is going to be connected to some other, it could either end with hydrogen or be connected to another carbon, whatever. But that little group right here is an aldehyde. Everything else is just hydrogen, carbon, hydrogen, carbon. Those are just hydrogen, like hydrocarbons. They're not going to be functional groups. Um, they're just going to be alkanes, which we've already gone over. Okay, so once again, I just see a bunch of alkanes right here. And then I come over here and I see CN and H, CN and, or say N and H down there. It doesn't matter which one, you know, that one there. Um, whatever the difference that you can tell obviously is that N is going to be in this one. And the difference that you can tell between amines, so amines and amide is that amines are going to have carbon, nitrogen, and hydrogen only. But amides are going to have carbon, nitrogen, hydrogen, but also oxygen. And let me just make sure. I think that actually might be a double bonded oxygen. Yeah, it's going to have a double bonded oxygen. And that's going to be an amide. So whenever we use that and we come and look over here, I only see the C and H. So that's going to be an amine. Alrighty. Now this one, this was a different type of structure. These were all condensed and Lewis structures. As this is going to be the skeletal structure, and this is obviously in a circle. This is going to be a cycloalkane. I'm pretty sure, I'm confident that you guys know that by now if you've watched the other video before this. Let's move on to number 4. First thing off the bat that I see, double bonded carbon to carbon. That's going to be an alkene. If you remember, double bond or single bond alkane. Oh, that's a little bit too big. Alkane here. I'm writing this all with a mouse, so bear with me. It looks kind of bad. And then double bonded carbon, that's going to be alkene. And then triple bonded, 1, 2, 3, it's going to be alkyne. And if you remember, just a little fun fact, the more bonds that they share between each other, like if there's only one bond, that's going to be a more secure bond. If there's 2 bonds, it's going to be a little bit less secure. 3 bonds, it's going to be even less secure. It's going to be more, you could break easily between these because the electrons are going to be further and further apart from each other. Now here I see just this is an alkane, alkane, alkane. Oh, but wait, I see an oxygen in there. Remember what that was? It's not going to be double bonded like it was up here, which was the aldehyde. This is just COH. So this is going to be alcohol. You see alco, co. All right, we're going to move on to the next one, to the next page here. All right. If I could get the annotator. Here we go. All right. First thing I can notice with this number 6 one, right off the bat, is this carbonyl, carbon double bonded to oxygen. So I know it's going to be one of the carbonyl group, or one of the functional groups that have carbonyl, which are going to be ketone, aldehyde, and amide, ester, and carboxylic acid. Here, let me make this distinction. Okay, so you have carbonyl, which isn't a functional group, but functional groups with carbonyl. I'm just gonna put GRP. groups with carbonyl. That's going to be aldehyde, and carbonyl is just going to be the double bonded carbon to oxygen. Aldehyde, ketone, ester, carboxylic acid, and amide, but not amine because amine doesn't have oxygen in it. Alrighty, so aldehyde, or sorry, we're gonna go back over here. These are the ones, these are the function groups with carbonyl. The ones without carbonyl here, it's without carbonyl, it's gonna be alcohol, ether, just gonna make these like overarching. With okay. Alcohol, ether, all the alkanes, alkynes, you know what I mean by that. And that is going to be it without carbonyl. These are the function groups with carbonyl though. So it could be, whenever I see this, I think carbonyl, it could be one of these, right? And what I see here is, oh, well, the carbon that's connected to, that's double bonded to the uh, oxygen doesn't have any hydrogen connected to this carbon. So immediately I rule out aldehyde. And ester, it doesn't have another oxygen in between one of these. So if let's say that if this was an oxygen here and this double bonded oxygen was moved over to this carbon here, then it would be ester, but it's not going to be ester for this one. So, and then also with carboxylic acid, this, if this was like, if this was double bonded oxygen here, and then this carbon was bonded to O, and then all of these H's would be gone but one, then it would be carboxylic acid. And obviously, if we had amide, there would be a nitrogen in there. So what does it got to be? It's got to be ketone because it has three carbons in it. There's, you know, three carbons connected here, but there is also like the carbon usually in the middle is going to be double bonded to the oxygen. Ketone. Now for this one, again, I see that carbonyl and I see it's connected to another carbon, but I also see the carbon that is connected, double bonded to this oxygen has a hydrogen to it. And you know what that signifies to me? That's going to be an aldehyde, right? Because aldehydes are going to be, they're going to be that co of alcohol. They're going to be that co, except the hydrogen is moved over here and the C and the O are double bonded. And that's what aldehyde is going to be. Once again, I see this. This is going to be a carbonyl one. They're a function group with carbonyl in it. But it's not like the others, if you recognize. See, if you look at aldehyde here, it has a carbonyl, and the carbon is bonded to hydrogen. But this one, or with it's bonded to hydrogen and it's also double bonded to oxygen. This one is double bonded to oxygen. And there is hydrogen, but there's also another oxygen. And this is actually a prime example of carboxylic acid. The function group, carboxylic acid. Alrighty. And now I see a bunch of alkanes. Whoop. Then I get to this one right here. Oh my goodness, what is that? What is that? COH. It's not double bonded, it's single bonded. That's gonna be, it doesn't have a carbonyl on it. It's gonna be one of these. And what does that look like? It's not two carbons double bonded, it's not two carbons triple bonded, and it doesn't have an oxygen in between two carbons, which would be ether. It's gonna be alcohol. alcohol. And then we go to this next one. First thing that I see off the back, oh, there's a double bond here. And it's between two carbons. Boom, instant. Alkene. Alkene is double bond. Alkyne with a Y is triple bond. All right. Now we go down to 11 here. I see C, I see N, and I see hydrogen. You know what I see there? And I don't see an oxygen, which would mean it would be an amide. And it would have a carbonyl because the amide is double bond. The carbon is double bonded to O, and it's also got a connection to the N, and obviously a hydrogen. So this one is going to be amine because it has no oxygen, which is an amide. Alrighty. And then we go down to this next one and I see there's a bunch of alkane, but in the middle here, I see COC. And when I see COC and there's no carbonyl, that can only really leave me with ether. That is the one without carbonyls. There's no double bonded, no carbon double bonded to oxygen. It's single bonded. So that's going to be ether. Ether and ester are really similar. See, if you were to take this, ester is just going to be ether, but with instead of having a hydrogen here and a hydrogen here, it would just be double bonded to an oxygen up here. And then I would change this to ester, but that's not the case. So I'm going to erase that. Alrighty. Here, big change. I see a triple bond between two carbons. That's going to be the alkyne with a Y. There's that. Easy. Those ones are easy. Now we're going to scroll down, or I guess that's the end. All right. Well, hopefully you do that worksheet on your own and let me know if you have any questions.